Okay, so far everything we've been looking at has been kind of to do with statics, and statics means that nothing's moving, so you're assuming your acceleration in your system is zero, okay? There's no movement whatsoever. We're now moving on to dynamics, which is where you cannot assume that your acceleration is zero unless you're kind of told to. Okay, so we're going to be using quite a bit of force equals mass times acceleration equation to resolve some of these systems. Okay, so the first thing is we're told that a particle is held on a rough horizontal plane. Okay, so here's my, on a rough plane, which is inclined to the horizontal at an angle of alpha. Okay, there's my horizontal. And I'm told that tan alpha equals 0.75, which is 3/4. Okay, so I'm just going to draw my little right angle triangle up the top, and you should do this every time. Tan alpha equals 3/4. There's alpha, opposite 3, adjacent 4, hypotenuse 5. Okay, easy 3, 4, 5 triangle. All right. I'm just going to put my particle in here. So here's my particle. Okay. Now I'm told that the particle has a do this in yellow. It's got a reaction force. Okay. It's got a weight force that we also don't know. It's got friction, which is acting up the hill, and has a coefficient of 0.5. So I'm going to put in a half r. And I'm going to put in the direction that my particle would want to move, which is down the hill. Okay, it's currently being held at rest, but it's going to be released and it's going to slide down there. So I'm putting that in there. Now, that's all my information. Okay, all pretty similar to what we've done so far. All right, the first thing we're going to do is we're going to find the acceleration of the particle. So to find the acceleration, obviously we're going to use our force equals mass times acceleration equation. And for that, we need to know the force, and we probably need to know the mass as well. So we've got quite a little bit to find. So I'm going to do my resolving vertically and horizontally. Okay, so if I'm resolving in a vertical direction, okay, then, and this is in line with the plane, then I've got r, that's one of my vertical components, minus, because it's acting in the opposite direction, mg cos alpha. So remembering that mg, if that's your angle in there, that's alpha, and you're using cos to find the vertical part of that triangle there. Okay, mg cos alpha. Now that equals to my mass, so that's my force, that's equal to my mass times the acceleration. Now in this case, because the particle isn't going to move upwards, it's only going to be moving in line with the plane. Okay, then my acceleration in the vertical direction is 0. Okay, so that's equal to 0 times by my acceleration, so r minus mg. Now I'm going to change this cos alpha into 4/5. Okay, so adjacent divided by hypotenuse, so times by 4/5. Okay, and that's equal to 0. Lovely. Okay, I'm then going to resolve in the opposite direction. Okay, so we're going to look at the horizontal components. So my horizontal components, a half r, okay, minus mg, now this is sine alpha this time, okay, for the horizontal component of that triangle there, equals to mass times acceleration. And I can't assume that's 0 because the particle is going to be moving and accelerating down the hill, okay, so I can't assume that in this case that's going to be equal to 0. Okay, but what I can do again is I can say half r minus mg, and I can change the sine alpha to 3/5, okay, equals to ma. Okay, now I'm just going to rearrange this equation, so I'm going to say r equals mg, so 4mg/5, okay, and then I'm also, half r, that should be half r, and then I can substitute that in for r in this equation here. So I've got half 4mg/5 minus 3mg/5 equals to ma. Now I can divide through all of this by m, because it's in every term, so divide through by m. And I get 4g/10 minus 3g/5 equals to a. Okay, so that would be 6g over 10. So 4g over 10 minus 6g over 10 gives me negative 2g over 10. Okay, so my acceleration would be negative 1.96 meters per second to the power of negative 2. Okay, from there for part B, I want to find the distance it slides in the first 2 seconds. So I'm going to use one of my Suvat equations. So I know u equals 0. I know a equals negative 1.96. I know that t equals 2, and I'm trying to find my distance. Okay, so then I'm going to leave that as s. So I'm going to use the distance equation. So s equals ut plus a half at squared, and that's going to be fine for solving for that. Now I've just realized that I probably shouldn't have a negative here, and I think that's because if I was resolving down the hill, if I'm looking at my motion down the hill, then this one should be negative and this one should be positive, because if I'm going down the hill, because this is your down and this is your up, so that's pushing in the opposite direction to where we want the motion to be going. So if that's negative, okay, then that should be positive, negative, positive, negative, positive. So we should get positive 2g over 10. So that should be positive 1.96 meters per second to the power of negative 2. Okay, so that should just be positive there, and then we should be fine. Okay, so then we've got distance. So u is 0, so that's going to be 0 plus a half a 1.96 times by t, which is 2, so 2 squared. Okay, so then s would be equal to 1.96 times by 4 times by 0.5. Okay, so it's 3.992 meters in the first 2 seconds. Okay, there we go. That's example 1 done.